Imagine sitting at a red light. On one side, a sleek electric car waits silent, smooth, almost otherworldly. On the other, your own petrol-powered machine hums with that deep, primal growl we've known for over 100 years. But as the light turns green, the EV glides away without a sound, leaving behind a question that feels almost unthinkable. Is this the beginning of the end for the combustion engine? Around the world, governments are cracking down on emissions, automakers are rushing to go electric, and the clock is ticking on the roar that once defined driving. We're not just witnessing a change in technology, we're standing at the edge of an automotive revolution. Chapter 1: A Century of Combustion. The internal combustion engine ICE is the core of automobiles more than 100 years old. The idea has not changed much since the first Benz patent motor wagon in 1886 to the high-performance supercars of today, burning fuel to generate power. Everything in these machines, including the carburetors, turbochargers, were refined over the decades by engineers who were able to get more performance and efficiency out of them. The V8 rumble or the high-revving V12 became part of the very car culture. Technology of ICE did not only drive passenger cars, but also influenced motorsport, logistics, aviation, and whole industries. Nevertheless, this mastery had its unarticulated penalty: increase of carbon emission, air pollution, and reliance on fossil fuels. These issues were avoided or reduced to a minimum over the course of decades. However, the outlook started shaking when scientific evidence toward the issue of climate change started gaining ground. Chapter 2: The Rise of Electric Alternatives. Electric cars are not a novelty. In fact, they were around way before combustion cars. The early electric vehicles experienced a surge in the late 1800s because the early electric vehicles could operate quietly and have a smooth performance. However, the short range and slowness on charging meant that soon gasoline cars replaced them. Jump to the early noughties, and the electric revival started. Tesla was one of those companies that broke the mold in showing EVs could not only be sustainable, but also thrilling. As some would say, in an instant, we had electric sedans capable of scorching acceleration, range, and other out-of-this-world features. Facing their environmental goals, governments started to introduce incentives and subsidies for EV purchases. These charging networks spread, and battery technology was advancing. Niche products turned into a mainstream desire. Electric cars can now appear not as compromises, but as status symbols and technological treats to the consumer. This increasing trend placed the conventional engine technology in a defensive position as it had never been used to before. Chapter 3: The Policy Push Against Combustion. It is not only the shifting tastes of consumers killing the old engine of combustion, but the killing is being put down by legislation. Governments across the globe are imposing firm deadlines on the sale of new petroleum and diesel-fueled vehicles, all but dooming gas-driven autos. The UK has pledged to exclude the sale of new petrol and diesel cars by 2035, and the European Union is fighting to see the same happen in all member states. In the United States, more ambitious targets are established in some states, such as California, that even have a 2035 limit in existence already. Not only are these not political sound bites and vague environmental pledges, they represent legally binding commitments. Car companies are racing to redesign their assembly lines, spending billions of dollars on battery, electric drivetrains, charging infrastructure, and new factories. It is not only the mass-market brands. Even the most iconic performance brands such as Ferrari, Lamborghini, and Aston Martin, which were once associated with the roar of a V12, are introducing hybrid systems and working on full electric supercars. The writing is on the wall in the case of the combustion engine. Each year that goes by creeps it nearer its obsolescence. And although fans may still get to hear the grumble of a V12 a bit longer yet, in our modern world, the clock is already well on its way to running down. It is not only the future that is coming, but something that has been legislated into reality. Chapter 4: Performance. Petrol versus electric. The internal combustion engine is king when it comes to performance, and the fact is that it was undisputed during decades. The sound of rolling thunder, V8, sound of screeching monkey, V12, and the burning fuel odor were the only few things that defined speed and excitement. The culture of the car was all about boasting horsepower, scorching top speeds, and Nürburgring lap times fanatics would debate about for decades. When you needed hard performance, you bought a machine which consumed petrol. Enough said. However, the electric vehicles have overturned the rules book itself. With a flick of the throttle, 0 to 60 miles per hour can be achieved aboard a very practical family EV, with the same level of ferocity that today embarrasses yesterday's supercars, thanks to the instant torque response. Consider Tesla Model S Plaid. It accelerates 0 to 60 in less than 2 seconds. A statistic only hypercars that cost millions of dollars used to be able to achieve. In a moment, this discussion of performance is switching off displacement and rev limits to kilowatts in battery control. Nevertheless, purists are someone well enough to answer that numbers do not reveal everything. It is not necessarily about the speed with which you get from point B to point A, but it is the experience of the feeling in between. The thrum of the exhaust, the rattle through the gear stick, and the fine sensation of getting a manual change exactly right all combine to make a brutally mechanical relationship between man and mechanical that no electric car, however fast, can ever really reproduce. It is possible that this sentimental, sensual experience is the lifebelt of the combustion engine. As the world electrifies around them, there is a good possibility these machines will live on as rare, niche, and enthusiast-level items, yearning for a more visceral, analog age of driving. Chapter 5. The emotional connection to combustion. To many people, over the decades, the internal combustion engine was not only king of the performance arena, it was the very definition of performance. Fans gauged the success of a vehicle by horsepower amounts, maximum speed, and scorching lap times at historic facilities, such as the Nürburgring. Their chat was a discussion of cylinder capacity, turbo pressure, and the sound of an engine tuned to perfection in which one got goosebumps. Having a high-speed petrol tank of a car was not merely A to B transportation, but drama, noise, and expertise of taming a well-prepared mechanical monster. Then came the electric revolution, and virtually overnight the game rules changed. Electric vehicles brought into the world of cars something that ICE cars could never provide: instant torque. No pre-revving, no shifting gears, powering through. It is an instant neck-wrenching burst of speed as soon as you step on the gas. This also implied that an electric family car that might look normal would easily outrun the usual sports cars. A record-setting Tesla Model S Plaid, the sleekest sedan, can accelerate to 60 miles per hour in less than 2 seconds, is the exemplary instance of how the subject evolved. In an instant, it was no longer bragging rights on cubic centimeters or RPMs. It was on battery output and software upgrades. However, with all that blistering torque, EVs even at times are sterile. Raw numbers do not tell the whole story, say purists. It is the growling of an engine, the vibrations, the feel of driving a manual transmission, the warmth with which you get when you drive a car, and the fact that you are within a machine that breathes and lives. The type of mechanical connection that will make you grin as you twiddle the throttle is not all that an electric car is likely to possess. Chapter 6. The challenges of going fully electric. As the adoption of electric vehicles is gearing up, quite amazingly, there are still a few hard bumps on the road to a fully electric future. Charging infrastructure is the first one and the most apparent. As opposed to the big cities, however, EV chargers in smaller towns or developing areas have yet to achieve the same level of popularity, and locating one may seem like trying to find a needle in a haystack. Chargers are not all high speed in nature, and even when they are, they may take hours to charge a motor car, unlike refilling a petrol tank that can take 5 minutes. There is the issue of raw material. Batteries need vast quantities of lithium, cobalt, and nickel, and mining these elements has their own economic, environmental, and human rights concerns. There may be constraints on supplies and cost volatility to production of EVs, and the carbon emissions of batteries have led to concerns over how truly green the switch will be. Besides, EVs experience some performance limitations under some conditions. Batteries also work less efficiently in colder climates, and the driving range is greatly reduced and occasionally the charging speeds. To those who have to travel long distances, i.e., truckers, rural commuters, or drivers going cross-country, EVs simply cannot compete with the utter convenience of a short fill-up yet. The above issues are not timeless. At current rates, they are being resolved with improvements in charging speed, battery chemistry, and recycling. But that transition will not happen in a matter of months. Meanwhile, it is probable that combustion engines will continue applying in the context of certain regions, industries, and applications that electric power is not feasible as yet. Chapter 7. Automakers preparing for the shift. Electric is already heavily bet on by the largest car makers. General Motors has committed to an electric-powered future by 2035. Volkswagen has put tens of billions of dollars in EV platforms. Even more energetic companies such as Ford are electrifying such legendary models as Mustang Mach-E and F-150 Lightning. Luxury auto labels such as Mercedes and Porsche are promoting the EVs that will not only be just as luxurious as their combustible versions, but also faster. This is the trend that is crossing the industry line and proves that the future is not a question of whether or not, but when. Chapter 8. What this means for drivers. The change will be a slow process to ordinary motorists. Combustion cars will not magically go away. They will still be sold secondhand in decades. Nevertheless, the availability of fuel and maintenance aid might decrease gradually with the market shift. Taxes and insurance can also be used later in favor of electric cars. The combustion vehicle owners who love their cars will have to consider long-term ownership plans, whether it is to keep them as collectibles or switch to hybrids before switching to fully electric. Chapter 9. Could synthetic fuels save the engine? Not all automakers are willing to see the combustion engine go off into history quietly. They are instead wondering about synthetic fuels, specially synthesized liquids that can be used in current petrol engines and diesel engines, but create virtually no carbon emissions. Unlike biofuels, which are produced by crops, are formed as synthetic fuels, or e-fuels, which are produced by a process involving use of captured carbon dioxide in combination with hydrogen that results in a cleaner burning product of the traditional petrol. Porsche is among the greatest proponents of the technology. The company has spent millions of dollars on e-fuel production facilities, saying these fuels may give high-performance cars, as well as more mundane vehicles, a second chance to live without the ecological guilt of fossil fuels. To car lovers, this might as well be maintaining the spirit and legacy of internal combustion alive well into the next decades. However, there is a twist to all this. In fact, it has many. There has already been huge increases in costs in the mass production of synthetic fuels as compared to the production of electricity, which powers in vast quantities of renewable energy are also necessary in the process to make it sustainable. There are criticisms, particularly those of the EV industry, that it is more efficient to burn synthetic fuels rather than burn the same renewable energy and propel electric motors directly. Not better, synthetic fuels could be significant as a niche. They would be able to keep old vintage cars in use without having to redesign them greatly, enable motorsport to maintain its iconic and most dramatic sound, and they may be a savior to industries in which electric technology has yet to excel. E-fuels are not a magic bullet to rescue combustion engines as they approach extinction, but they may be a defibrillator to give the heart a few more beats. Chapter 10. The likely future. It is no longer in doubt that the future is electric by the majority of experts. By 2040, more than two-thirds of new car sales will be EVs, and the remaining combustion cars will be at best hobbies, in rural markets, or industrial niche markets. However, in a similar way that something as seemingly obsolete as vinyl records can withstand the so-called streaming revolution, the same may happen to combustion engines. They will just grow to be less common, more costly, and treasured by those that appreciate them. The death of the traditional engine isn't an overnight event. It's a slow, inevitable shift driven by technology, policy, and culture. Electric cars are faster, cleaner, and increasingly more practical, but they can't replace the emotional bond many drivers have with combustion engines. Whether you welcome the change or resist it, one thing is certain. The future of driving is about to look and sound very different. The roar of the engine may fade, but it will never be completely silenced.